Hi, in this video I want to talk about a very important concept in object-oriented programming, and that is the idea of encapsulation. So let's think about why we're making classes in the first place. We want to have data, and we want to have some services or operations on that data, and a class is a way of coupling those two together in a sort of a tightly connected way. Before this, we had to have data stored in variables, and we'd maybe have static methods that worked on them, but it was our job to put those two things together. And with objects, we can kind of more carefully connect those so they work together. Then we want to put some sort of barrier around the data to keep it safe from other code using it in unexpected ways. We're always working to control complexity in our projects and code, and classes are a good way of creating little chunks of code that have well-defined behavior and that people know how to use well, but that don't intermingle with other code very much. So one way of doing this is the idea of encapsulation, where we have internal data in a class, and of course that's the instance variables of the class, and we're going to make those hidden from other code, so other code cannot directly access them. And then we provide a useful interface to that data through methods of the class. And we care about this again because encapsulation makes safer code, in other words, less prone to having errors, and helps us maintain code. And I'm going to show you some examples of this in this video. So let's make a circle class. And if you think about a circle, well, okay, maybe it has, it could have a center point and move around the screen, but we're just going to consider a circle to have something with a radius, right? So I'm going to make it a private. That's the access control. The access modifier for this says when it's private, it can only be used inside the class. So I declare the instance variable. Notice it's just hanging out in the class, right? It's not a part of a method or anything like that. And then I'm going to make a public constructor, which again has the same name as the class, and give it some parameters to start off with. And I'm going to assign that initial parameter to the radius instance variable. Initial radius. Okay, so I think there'll be more in the class, right? Computing things about it and so on. But for now, this is sort of enough. So here we have this private radius, and let's say we're in another class and we're going to make a circle equals a new circle with a radius of 10, something like that. Oops, I didn't declare the type of this thing. Okay, circle. Okay, a lot of circles here. Capital circle is the type, the class, right? Lower circle is the name of the variable, and we're using the constructor to make this thing. And in here, if I try to access that radius, it doesn't let me, right? So if I wanted to assign a value to it, for example, it's going to say here, the field or instance variable circle without radius is not visible. In other words, we can't access it. That's a good thing. So let me go back here, and I'm going to be like, okay, I wanted to do that, so I'm going to make this public. And now code outside the class can access that instance variable directly, like here. And maybe rather than, I'm going to just print it out, right? So I don't have any way to print it out right now, so I'm going to print out I'm just going to print out the radius. The radius is circle dot radius. Okay, and I can actually run this program now, hopefully. And if I go look at it, the radius is 10. Okay, we set it, and we got the value. And this all seems pretty natural, right? Now, the thing is, here in circle, we made a design decision to store the radius, and it may be that for various reasons, we want to change that to diameter. And I've changed this here. And Oops, wow. And I can actually keep this radius if I want, and I can just say make that 2 times radius because the diameter is twice the radius, and assign that to diameter. So it's not even a one-to-one. It's not always like some value comes in and you assign it directly to an instance variable. Sometimes you modify it or something. And I might feel like my job is done because let's say I'm at a company and I am the circle person, right? And so my job is to keep circle up to date, and I just change this and say I'm done. But now someone else in my company who wants to use that has code here that uses radius. And so there's this maintenance issue that, in other words, when I change this here, maybe I have to search by myself, like through all the files and the million files in my big company's project and change them all everywhere that they're used, or send out a note or something, and people are responsible for keeping up with these things. But you can sort of imagine this is a struggle. People are changing stuff all the time, and if you allow this public access, people will start using those things, and then when you change it, you can't predict how difficult that change is going to be system-wide, because you're only aware of the code you wrote, not the code that other people wrote that uses your code. So that's a bad thing. We need to control how people use Circle, and one way to control that is, do not allow them to have access to these internal things storing values. Instead, what we want to do is provide some sort of well-defined radius, well-defined interface, and I'm going to do that by writing some methods. And in fact, we're going to use what we call a getter, right? That gets a value out of the internals of the class. And I might have a public and a getter, since the return type is the type of the thing you're trying to get. And I'm going to say get radius. There's no value coming in. It's going to ask the object what its radius is. And I'm just going to return diameter divided by 2. Okay? And I made this public, which means other people can use it. And so this person here should be using get radius. It's a method call, so it has the parentheses on the end. So now we're sort of happy, right? They can get the radius out, and I can provide the radius by doing some math on the stored diameter. But the other thing is, I can actually now, if I change this back to radius, then I have to do some work, right? I'm updating my code. Change it here. But the only place I have to change it is in my file, right? I changed the internals of this class. The public interface, what the rest of the world sees, stayed the same. And so the big difference between me being responsible for my code and being able to update it, and having to update like the entire system that a whole big group of people use or something like that, right? There's an enormous difference in complexity between those two behaviors. So this private instance variable and then providing this kind of thing keeps things consistent. Now you might say like, well, you had diameter before. Maybe people want diameter, right? Well, I can actually add several of these things. So I can actually provide options for people because I want to make a good interface that people want to use. And so I'm going to make, I don't want to return radius divided by 2 for the radius. I'm going to return radius times 2 for the diameter, right? Now the people using the code have no idea if I'm storing the diameter or radius inside here. I mean, they can look at the code and figure it out, but their code doesn't know. And in some ways, it doesn't matter. They can ask for the radius, they can ask for the diameter, and I can provide both those values by doing a little computation on my internal design, my internal storage. Now I can do a setter with the same kind of thing. So I can do public, setters are void. They change the internal structure, but they don't return a value. Void set radius, and I'm going to call this new radius. And I'm going to set my radius instance variable to the new radius. Okay, and I could write a set diameter as well, right? Where a diameter goes in, and then I do some math on it and set the internal radius. And again, no one's really the wiser about that. So again, once you get into this spirit, you just provide stuff that you think people will be find useful to use, and you provide enough options that hopefully your interface can stay stable as your internals change over time. And people can ask for the kind of information that they want without having to understand exactly what's going on inside your class. Now I could do some additional work in here, right? I can say if new radius is less than 0, perhaps we want to set the new radius to 0. Again, that should be some sort of behavior you're describing in your documentation, right? Maybe you want to throw an exception, maybe you want to just clamp it, but I can do things to make sure that in some ways my internal state here is meaningful and legal. So I can do stuff to protect people from changing things in ways I don't expect. So here, and I should have that same kind of thing up. I have that ×2 there as well. I need some JUnit tests to make sure I'm not changing things and failing, right? So I could have protection up here as well, making sure that never goes negative. And then the rest of your code doesn't have to keep checking it. It's a sort of can be sure that the radius is never negative. Whereas if this were public, again, people could do all sorts of things with it, right? Make it negative, and I have no way of controlling that change. So again, by making this private and then controlling the access to it, I can basically make concrete various assumptions I'm making about these values, and it simplifies the rest of your code. Okay, so that may seem like a fairly, like there's not any new Java here, right? This is all just talking about what we learned last time with classes, but this concept of encapsulating is critical to the design of a class. And when you're making your own classes, you need to think about, okay, what is stored, and how do I want to provide access to it in a safe and consistent way to other people? All right, thanks.